Hey, what's going on, folks? It's Mike here, and welcome to the Deep Programming Language series. In this lesson, we're going to pick up and talk about writing files. That is, if you saw our previous lesson, I talked about how to read information from files, but this time you might want to save information out of your program as it's running, so you'll need to be able to write that and store it in disk somewhere. So anyways, that's how we're going to talk about our writing of data for today. Of course, you can write to other locations like networks and so on, but we're just going to talk about files in this particular lesson. So with that said, let's go ahead and dive in. Now, what I'm going to go ahead and take us from the dlang.org webpage is documentation, library reference, and we are doing things with standard input output. So you can go ahead and search for that. And then it'll also be useful to open up the file module as well, so that you can see some useful utilities again for working with files. I think we're going to mostly work with standard input and output today, this time again focusing on writing of files. So let's go ahead and click on this file struct here and take a look at it. Now again, a file is going to be pretty similar to if you've used it in languages like C or Python or pretty much any other language. One difference that I will note here, and we'll get to it in a moment, is that the file, there is a little bit of an abstraction in the deep programming language, so you don't actually have to close it. It is sort of reference counted here. So I did that in the last video. I just wanted to make a small correction there if you're following along. It might be nice to explicitly close it just out of habit. Again, you can find that there is a close function here. If it wasn't closed, or if you don't want to wait till it goes out of scope. Again, out of habit, I probably use close, but again, D is a pretty safe language, which makes things nice. So anyways, where we're going to start off from here is just to show you the active files in this directory. And again, I just have my source file, so we're going to be creating some more here as we create our file. So let's go ahead and follow this example here just a little bit for creating files. I'm going to explicitly create the file struct as is shown here. File, just call it F to follow along. And then again, as shown here, we have for our constructor, for a file, the file name, something like test.txt, so it's a text-based file, and then what we want to actually do, the mode, W. Now this is something that I didn't talk about as much last time, and what this is going to do is it's going to, with the W mode, it's going to create the file if it doesn't exist, and then it'll open it up for writing access. That means that we can append lines to this particular file. Now, how do we append to it? Well, the good news is we can use a lot of the standard input-output operations that we've learned previously, and I can just do f.writeLine, and something like hello world will do the trick here. So let's actually run this program here, and then you'll see again there's no output, because this time, where am I writing that line to? Well, this file here, that's where the output is. It's not standard out, which is just our terminal, but it's whatever the handle is for this file. So again, just to sort of illustrate what's going on, again, if this is your first time working with files, when I have some process that is running, so that's my actual main application when I'm running it here, or the executable, I have various segments of memory. And we've talked about this a little bit in our series here if you've been watching since the start, but the basic idea is I have different segments of memory, things like the stack, the heap, and so on, the actual data segment here, and the code or the text here. So anyways, that's how our process is sort of divided. But you can also imagine that the operating system is keeping track of handles to various files. I'm just going to draw this in a separate little table here, and sometimes you'll hear me say handle, or the actual term that we think of is the file descriptor. File descriptor. I'm just going to label this as file, and let me write it out here. Sideways descriptor, just so you have that search keyword. And often you'll see this abbreviated as FD, just in case you see that. So that's why I wrote here a little bit crooked. And you have some of these open with each process by default. Things like standard out, standard in for when you're reading files, and standard error. And again, these are just integers that tell us where to sort of write to. And when I open some other file here, like F, which I'm just going to add to this table as something else that we added here, it has its own integer value here. Okay, now I might have written these out of order and what they actually are, standard in, error, and out, but let's just go ahead and call F, 4 here. It's the fourth one, whatever integer it'll be added to, and that's all it is. That's how we sort of identify which file or place that we will then write out information to. And then this actual file descriptor usually has some other table, again, depends what operating system you're using, that stores the information that you care about, like the actual file here that has a name, the size, when it was last modified, all this sort of meta information, where you're actually writing to, what the current position is of the file, all these different things here. Okay, so those are the different pieces of information that we might have there. So anyways, that's what's actually being done when we write out to a specific file here, rather than just defaulting to the standard out, which is our terminal, which in a sense is its own file, displaying its contents. So anyways, I have created this file here, and you understand a little bit about what files are actually doing. And we can see that we have hello world here. So that's pretty neat here. Now, again, the next thing I want to talk about is these different types of file modes here. And there's a bunch of them. Okay, so we have W for writing. If I did R, that means this is a read-only file, so I can't call. In fact, let's just try to do it here. Let's just open this up for reading and then try to write for it. Let's see what happens in our actual program. We get an exception here, okay? Because it's saying, hey, you open up this file here, you specified reading, but you're trying to write for it, okay? So actually an important, sort of argument to use here. But you do have things like, for instance, and again, you can look up these tables. I just know some of these, like W+, which is read and write. So I could do something like this. This would be legal. So I could actually do f.readline. If this file exists, and then actually write to it. Let's just go ahead and store here value equals this. And then we can actually write line to standard out what is in file. And we'll write out the value. So something like that. So what is in the file? Oh, looks like it didn't find it. And I have to actually be a little bit careful with W+, because we can read and, let's actually make sure we spell write properly, but it will empty contents of the file. So again, you can just kind of play around with these. Versus R+, again, you can imagine that there's this enumeration of these different file modes. I can read if file exists, and I should say read and write from start of the file here. So let's try this here with this mode. Now I can actually see, hey, we have hello world here, and then we're going to essentially overwrite its contents with, let's just make these uppercase, for example, hello world. And again, you can see that previously what we had in our file was hello world. And then if I actually look at the contents now, after I have read in from this file, I have now written hello world here. Okay, so that's kind of neat. And then we also have modes for appending. Let's just go ahead and do A for append mode. Let's see if this works here. Again, we're going to get a little bit of a problem here because, we can't, basically this is open up the file to append or add to the end of the contents here. If the file doesn't exist, no problem, then we'll, open it up. But we need to actually get rid of this here. And then our program runs fine because we can't read from it. Let's actually see what that did to our file here that added a hello world here. So if I run this program again, and then I look here, we add another hello world. And if I run this program again, we have yet another hello world here. And if I do want that read access, again, let's go ahead and add, follow the pattern here, A+ here. So A is append, and A+ append and read. Okay, so let's go ahead and see what that does here. So now I can actually run this application. It'll read the first line here as it's following, print it out, and then we'll keep appending hello worlds here. And our file just keeps getting longer and longer here. Oops, let's actually write out the text here. So there were 6 lines there. Let's go ahead and run it again with our main, and then we should have 7 lines here. If I actually display the right file here, I'm going to keep doing that. Hello world. Okay, so that's pretty much it for writing to the files and the different modes here. So now that we understand that, but let's take a look at some of the other things that we can do here. Again, we can write out various pieces of information here with write here, let's actually see some of the other things that we have. Now, one of the things that we can do that's kind of interesting, we've got this locking text writer here. Outputs range, which locks the file when created, unlocks the file when it goes out of scope. So that's kind of interesting that we can only write to one particular file, because again, you might try to open the same file multiple times. So this looks like something that's built in for a lock, and there's different ways to also write in binary information. That's pretty cool here. From some of these different examples, we can write out formatted data here. Let's go ahead and see how we can use some of our other write functions here. What I'm going to do is just call this test2, and then let's just open up one file for writing here. Actually, I'll keep this example here. Let's just comment it out here, just in case you want to have that available to look at. Sometimes it's useful for me, but let's just go ahead and do file, F2 equals file, test2, and we're just going to open this up for writing. And let's do F2 write, and we're going to do a formatted string. So we use our format string specifiers, and let's just go ahead and put in some data here. First equals Mike, and then some other information, job equals, teaching, something like that. So first and job. So if you wanted to kind of write out some formatted data here, we could do that. So let's go ahead and run our program here. Looks good. And then let's make sure we open up test2. Make it say Mike and teaching here. Okay, so that's a way to write out some formatted data. We're going to start working with some formatted data later on in this series. So of course, make sure you subscribe so you don't miss that. Let's go ahead and look at that. So you can see if we want JSON data, comma separated data, and so on. Those are some different things that we could do. Now, also of interest is probably to work with some other types of information here. Let me just kind of take a quick look here. So again, looking through our file, we can see some of the different attributes of our file, checking if it exists, if it is a file, some of these things that might be useful. We can rename our file from these general utilities. So again, we have some useful stuff there. Let's go ahead and see. I think there's an interesting to file. Yeah, let's play around with this a little bit here. So this will write an array or a range to a file. This is kind of interesting. So let's go ahead and play around with toFile. Just want to try something a little bit less trivial for this video here. So let's go ahead and just using auto, just say data, and we'll do something like that here. And let's do F2 to file. And let's go ahead and take our data. And then this string is the file name, sumfile.txt. Let's go ahead and see what happens here. Just playing around with some of these functions here for writing data. Okay, it says none of the overloads of template standard std to file are callable using this argument. Okay, so let's figure out what we're doing. And if I just look at this, let's see. Okay, so none of these overloads. F2 is, sorry, I should get rid of this here. To file here. Okay, so we just wrote our data here to this text file. Let's actually see how it wrote it out here. So vim some file here. And interesting, we get a bunch of what essentially looks like garbage here. So again, if we look at to file here, we are writing here this as, well, it looks like we're encoding it as binary data here. Okay, so let's actually try to read it. This is something that we didn't do here because, if we have something like this data that we actually just want to read here, we need to think about, we could use the write functions to just write out the data. In fact, let's play around with this just a little bit more. Let's go ahead and see the difference here. If I do F2 dot write and data, let's see if we can do that first and foremost. Okay, so let's hide this experiment for a moment here. I have that handy function here. And this just lets us write out this array here. Let's see how it gets written out in test2. And in fact, it is writing out, well, quite literally this array of data here. So that's actually kind of nice that just works in D, looks like here. Let's give ourselves an end line at the end of our first write here. And then we can just write out that data. Now we might want to, again, it depends, if you want to walk through this range and write it, right, do not want the brackets here. It's literally writing out that slice here, that dynamic array that we have here. So that's kind of cool here that we actually just preserve that, and it's easy to see and it's already formatted. So if you're writing this out to JSON or some formatted file, again, you would have this structure here. Okay, but now let's go ahead and look at, and let's rename this to binary data here. So we're going to write a file in binary, and then let's go ahead and read the file in binary. Okay, so let's go ahead and let's see if we have some on our read functions here where we want to do our reading. And let's go ahead and see if we just open a file for reading. File f3 equals file binary data.txt, and then we're opening up this for read. And usually you could put a B here for binary. So we'll go ahead and try that here. And then let's just go ahead and use some of the tricks that we learned previously. So what we're going to do is say while f3.read does not equal the end of file, then we will just go ahead and keep reading. Or I suppose this is sort of a C way of doing things here. So let's go ahead and here, while we're not at the end of the file here, sort of do it this way here, while not end of file here. And if we know what information we actually have here, I guess this is sort of the trick when we're reading in the binary data. That's part of the trick here. Again, if we're going to write out data in a structured format, we need to read it in a structured format. So I sort of happen to know that maybe we want to interpret these as integers that have been written here. Now we'll go ahead and see. Let's just go ahead and read these as characters here. Data equals read. And let's go ahead and just write a new line here to standard output for each of our data that we're reading. So again, let's just play around with this a little bit here. It says, okay, undefined identifier read here. Did I mean fread? Yes, I did here. So let's go ahead and find fread. Oh, and there is a raw read here. Again, if I know sort of the size and so on of my buffer. So that's kind of neat. Let's actually look for fread though, because we want to read from a file. Let's see, is that's in the utilities here, fread. I guess we just have read from our files. So let's go ahead and do, what did I miss here? Oh, let me do f.f3 read. And then let's go ahead and do a few things here. Actually, let me do this a little bit of a different way, just looking at this here. And I could kind of see, well, actually, the easiest way to do this, let me back up here and just do the, I know I have an array of data here, so let me back up here just to do a, what was it, raw read or something like that. Let's see here. Read with a, yeah, raw read should do it. I don't know why it's not showing up in here. Oh, maybe it's in standard IO. Raw read. Okay, yeah, let's just go ahead and use this. So I could just read everything in from this file buffer here. Yeah, let's just kind of structure it here. Auto. Let's see, my data. And let's just do this from a function call here. Raw read. Now again, I could read from a file, you know, and store inside of this buffer a few characters. I'm just going to read in everything here, which is what it's going to do by the default setting here. And then let's actually just write out those characters here. Write line, my data here. And this should be storing it as an array. That's what this type should be here for a raw read. So always reads in binary mode. Okay, on Windows here, it's saying. So maybe something else on some other platform. Let's go ahead and run that much here. Let's see. And maybe I need to include import standard file. Let's go ahead and just wrestle with that. Undefined identifier raw read. Let's see, did I spell this wrong? Maybe this is one of the utilities here. So let's back up here a second, find our file structure here, and then raw read. Okay, I guess I do have to do this through a file here. Okay, f3 equals, and then we'll go ahead and say what the file is. This makes it a little bit easier here. Let's just do f3 dot read here, binary data .txt that we're opening up for reading in binary mode. Okay, so that kind of wraps things up nicely. Let's give that a try here. And it looks like it is just wanting the actual buffer where we're going to store things here. So I guess we could sort of think about how many, okay, the number of items to read and the size of each item. Okay, is inferred from the size and the type of the input array. Okay, so let's actually just allocate here. And we know we have integers. Again, this comes back to the sort of structured data here. So we could do a series of raw reads, and I'll do that in a moment here, just to keep playing around with this here. Or actually, I'll just get this working and then talk about it. So we know we have 4 integers. The data is an int, so each of these are probably are 4 bytes, at least in D, as is specified here. So we have 4 of those. So this is going to do a raw read into this array to store these 4 integers here. Okay, and then I'll write out the data, which is going to print it here, and then we'll actually just look at this data, and then I'll wrap things up here. So there we are, 1, 2, 3, 4 here. Sorry, I was trying to do things a little bit in a C way, but this is probably how I would read if I knew I had some structured data, or one way to do it here. Again, if I have some other type here, or if I'm reading lines that are, again, I can read formatted strings here as well. I could do readf, or I could do these raw reads and just store or allocate those into my actual type here. That works just fine here. So anyways, let me go ahead and wrap this up, because I've kind of gotten a little bit away from the actual point of this, which was focused on writing of data here, but got into a little tangent because it's important to know how to read and write binary data or different types of data here. Anyways, just to review, we looked at the different file modes here where we open files, so we know how to work with those. We looked at writing to files with some various experiments, again, practicing with these modes here. And then I got off on a little bit of a tangent here, finding some fun functions for writing out binary data here, so you can just write out straight arrays of structured data. Again, maybe we'll get into this in a future video on serialization of data, and if you have a struct or a class, it might be useful to write out some serialized and deserialized functions. So then you could just quickly, essentially have your own quick and easy raw read functions from those structures, or raw writes to just write out bytes of information. And that's how you do things in games and applications, for example, for loading and saving files to your disk. So anyways, folks, I hope you enjoyed this lesson. As always, if you're enjoying these, you can find these on courses.msha.io, as well as some other ones, and follow along and track your progress if you sign up there. And thanks for joining me for that lesson. I hope it was fun. I hope you didn't get distracted by my little tangent there. It's kind of fun to play around with the code sometimes with some of these functions. But anyways, thanks for your time and attention as always. Hope you're having fun programming with D. And with that said, folks, I'll see you in the next one.